students struggle with limiting reactant problems, not because the calculations are difficult, because they forget to look for them and apply the principles that we're going to learn here. So let us consider a limiting reactant problem. In this lesson, we're not going to just look at limiting reactant, but we're going to look at something called theoretical yield and percent yield. First of all, what is a limiting reactant? Sometimes called a limiting reagent. This is the substance that gets used up first in a chemical reaction. So let's say we have a reaction, there's reactant A and reactant B, and we just dump some of each of them in there and put them in a reaction chamber and let them go to town. The reaction is going to take place until it uses up one of them, and then it has to stop. So the one that gets used up is called the limiting reagent. If it's not the limiting reagent, it is the excess reagent or excess reactant. Okay? This is a substance that isn't present in greater than the amount needed to allow the other guy to react. So you have some of it left over. Okay? So you make sandwiches and you have 10 pieces of bologna, but you only got 4 pieces of bread, and you're going to put 1 piece of bologna on each piece of bread. You're going to have way more bologna than you need. That's an example in cooking. All right? Or you're going to make cookies and, well, you get the idea. If you got way more of one thing than you need, it doesn't matter. It can't make more just because you got a lot of it. It gets used up. I mean, it doesn't get used up all the way. The other stuff in there gets used up first. So limiting reactant, excess reactants, or reagents. So we're going to look at a visual example to begin with, okay? So let's make this decoration right there, all right? We're going to make 2 holly leaves and 3 holly berries for let's say I want to have a Christmas dinner and I want to make a bunch of these for the holidays, all right? And I go into my bag and I discover what I've got inside of my bag. I discover that I have got, well, what do I have? Does it say? Yes, I want to make that. I've told you that. 2 holly berries, 3 berries and 2 leaves, and this is what I have. I find in my craft box that I have 12 leaves and I have 15 berries. And I want to make exactly what you see on the screen. Now use your own logic and tell me how many decorations total I can make that look like that if I have 12 leaves and 15 berries. Well, hopefully what you said is that you could only make 5. Okay? Now let's think about the logic of that and how you came up with that answer. There's a couple different ways that you could have come up with that answer. Here is the most common way. When I have a class of hundreds of students, I'll ask them to tell me, how did you come up with that? This is the most common answer. People will take the leaves first and say, well, if I had 12 leaves, I could make 6 decorations. All right? Okay? Because it takes 2 for each one. And if I have 15 berries, then I could make 5 decorations and use up all the berries. Well, there's not enough berries to make 6 of them, so this has to be all I can make. I can't make 6 just because I had enough leaves. We would call this the limiting reagent. It got used up. We would call this the excess, because there's more than is needed. If you can only make 5 decorations, then I'm only going to use 10 of those leaves and I would have 2 left over. Now that's the logic we're going to use as we do these problems. We're going to figure out how much product you can make starting with either this or this. And then choose the one that makes the least. And that will be your answer. So you have to first identify that you're dealing with a limiting reactant problem in order to do a limiting reactant problem. And that's why I say this is not complicated. We're not learning any new calculations. It's the same old calculations we did in our previous lesson. But you have to realize it's a limiting reactant problem and then do it twice and choose the smaller one. If you can recognize it, you're home free. Okay? So how are you going to recognize it? Well, they're going to give you measured amounts of both reactants. or if you have 3 reactants, they'll give you measured amounts of each of those reactants. When they give you measured quantities of each one of them that will enable you to get into moles, then you are ready to do a limiting reactant problem. And what you're going to do is you are going to do the problem twice, choose the one that's smallest. Now, I don't want you to think that this is the only way to solve this problem. There are other ways to solve this problem. And if you go and watch other videos or you read in a textbook and they show you another method of doing it, they're not wrong. It's just that I know that thinking through the logic this way is what most students do, and so I will model that as we work through these problems. Okay? So the procedure is figure out how much moles, that's a number, right? Moles of product are formed for each of the reactants given, and figure out which one produces the least. This was the least of product. Now, you can make a comparison at moles, and then once you figure out the least, then you can finish the problem based upon the smaller one. Now, you could go on and calculate the final answer for everybody. It just saves you a little time if you do the comparison in moles, and here is our examples. Okay, we'll start with this one. How many grams of water are produced when 4.5 grams of hydrogen reacts with 7.5 grams of oxygen? Now, what you do not want to do is look at those two numbers and say, well, I know it's a limiting reactant problem, so I want to base it upon the 4.5 because that's a smaller number. That's not where you made the comparison. You don't make the comparison until you get to the final product. Then you can make the comparison. So we will start with the 4.5, and this is grams of hydrogen. And we're going to go to amount of product formed. So we first have got to go in, pull your map out and look at it. From grams of hydrogen to where? We're going to go to moles of hydrogen. All roads lead to moles first. So we get the molar mass of this hydrogen, H2, so many grams in a mole. And then we're ready to go over the bridge from moles of hydrogen to moles of the product they're asking me about. They're asking me about water. And this is the moles to moles where we go to the balanced equation and we see a 2 with this and a 2 with this. And that is going to give us a value of 2.23 moles of water. I've gotten to a number of product formed, just like I figured out how many decorations up here. Now I'm going to go to the other piece of information. I have 7.5 grams of oxygen. So the first thing I need to do is go from grams of oxygen to moles of oxygen. Got to get into moles before you can go over the bridge. So 16 times 2 is 32 grams in a mole. Now I can go from moles of O2 over the bridge to moles of the product, which was water. There's a 1 with the oxygen, and there is a 2 with the water. And when I divide and multiply on this step, I have 0.469 moles of water. So even though I started with more grams of oxygen, this is the one that produced the smallest amount of water. So I'm going to finish the problem on that smaller quantity. So I take my point, 469 moles of water. And what they really asked in the problem is how many grams is that? So now we're ready to say, I don't want moles of water. I want grams of water. And that's 18.015 grams in a mole. I multiply that out, and I have 8.4 to two significant figures, which is what this was all based upon. And this would be grams of water. Now you'll notice I didn't do any new calculations. All the same calculations we did in the previous video. I just recognized that I needed to do them twice for both reactants, choose the smaller, and finish the problem with that. It would have been okay to go on ahead and get grams of this and grams of that and then choose the smaller, as long as you're comparing exactly the same thing when you're choosing the smaller. Here I chose it. I compared decoration to decoration. Here I'm comparing moles of water to moles of water. If I'd gone on to grams of water and grams of water, I could have made my comparison at that point. I choose to do this because that's one less calculation I have to do. And when an exam rolls around, having time to get done is helpful. Okay, what's next here? All right, so we had our map. Oh, it's not going to be in this video. We're going to go up with our next and talk about percent yields, actual yields, theoretical yields, and what all of that means when we're doing calculations